So continuing on here, we want to separate and integrate. Okay, so we're going to separate these variables. So 5y squared goes with the dy, so it's cross multiplying basically. 4x dx. Now, these constants, it doesn't really matter where they go. I could have left the 5 here, like that, or I could have started like this, and I could have actually put the 4 over on this side. Doesn't really matter. The constants, it doesn't matter which variables you associate the constants with. If you want to keep them out of the denominators, you can do it like this, but no big deal. We're going to be integrating this, and the constants aren't going to be affect the integration anyways. So here we get, when we integrate both sides, I get 5y cubed over 3. And here I'm going to end up with 4x squared over 2 plus c. Okay, and then we can solve. This is the general solution again, and we can now leave it like that, implicit form, or we can actually solve for y. So if I solve for y here, I'm going to end up with, this is going to be 6 over 5 x squared plus, and I'm just going to call that c2 because it's just some constant multiplied by 3 over 5. Okay, and then this solution is going to be the cube root of all of that. Okay, and the only reason I put c2 is just so to be clear that this c is different from this c, but it's still a constant. Okay, the constant value is still a constant value. It's just a different constant value based on my algebraic rearrangements. If you want to write this as C3c over 5 instead of c2, you're more than welcome to do that. But it is a constant, so it seems easier just to leave it like that. Okay, so these ones here. Okay, well, let's do one more, and then I'm going to show you ones where we actually can solve for c. So again, this one here, notice the differential equation. This one now is not dy by dx equals. Now it's all in its implicit form. Okay, we can have the y prime embedded in the function as well. But as long as we can separate the y's with the x's, so here I'm going to do 2 root y dy. Okay, I'm going to multiply the dx on that side, this side here. Now, to get rid of the root x, I'm going to divide on both sides by root x. So the root x ends up in the denominator on this side. So then integrate this. Okay, this becomes 2 y to the 3 over 2 divided by 3 over 2. Okay, so 1/2 goes to power 3 over 2. This one, negative 1/2 becomes positive 1/2 by adding that, plus c. Okay, rearranging this, I'm going to end up with 4 over 3 y to the 3 over 2 is equal to 2 root x plus c. Okay, so again, this is this general solution in its implicit form. I can solve for the y. Okay, and not all of these, by the way, you're going to be able to solve for the y, but solving for the y here, I'm going to end up with 4. It's going to be 6 over 4, so I'm going to simplify that to 3 over 2 root x plus, again, I'm going to just make that c2, and y is equal to, putting that all in brackets, I'm going to undo that with a power 3 over 2, so it's 3 over 2 root x plus, we'll call that c2. Okay. So this is our solutions, our general solutions for the differential equation. So there's a whole bunch of equations that will fit this criteria of getting a derivative like this. And the different ones, depending on where they are positioned in the graph, we can solve for C2. So that's the next part here. The last part here is we're going to actually solve for C. So if we know where that graph crosses, it has slope like this, but it goes through, and this has a whole bunch of solutions that are different plus C's, but specific plus c will go through this point. So again, I separate and I integrate. Okay, separate, integrate, I end up with log y is equal to x cubed plus c. Okay, I can solve for c at this point, so I'm going to do that. So I'm going to plug in 1 for y, 0 for x, my plus c. In this case, this is all equal to 0, so I have a plus c of 0. So then I can rewrite this equation of log y equals x cubed plus 0. This specific equation passes through that point. If I want to write this with a y equals, I end up with this equation. And again, if you want to confirm, x is 0, y is 1, yeah, that is a specific solution that will pass through that point. Okay, so the same thing here, we'll look at this. We're going to separate and integrate. This one ends up being y times dy. I'm going to leave the 2 on this side, so we get dx over x. Integrate. Okay, so we end up with y squared over 2 is equal to 2 log x. Okay, plus c. So I can solve for y, but before I solve for y, I'm just going to solve for the plus c. So I'm going to go y is 2, x is e, so 2 squared over 2 equals 2 log e plus c. Here we end up with 2 squared over 2 is 2. Log e is 1, so we get 2 equals 2 plus c. The c works out to be 0. Okay, so c equals 0. So I end up with this specific solution that looks like this. Y squared over 2 equals 2 log x plus 0. Okay, we can leave it like that, or this is easy enough to solve for y, so we're going to solve for y. So it looks like that, and I'm going to square root. So I get plus minus 2 log of x. Okay, so there is a bit of restriction on here in that the log x we're not going to end up with negative logs, so there's going to be restriction. X is going to be bigger than 0, bigger than 1 when we actually graph something like this. Okay, so but this one has a specific solution. There it is, and there's my point. This graph goes to that specific point.